Dr. Narottam Sahu, Advisor, GUJCOST. Dr. Poonam Bhargav, Ma'am, Principal Scientific Officer, GUJCOST. Professor Kunjan Shah, Professor, IITE Gandhinagar. Mr. Pavit Shah, Scientific Officer, GUJCOST. આ બધાને હું તથા સ્ટુડન્ટ્સ અને બીજા IIT ના ટીચર્સ, પ્રોફેસર્સ બધાને હું નેશનલ મેથેમેટિક્સ ડેમાં હાર્દિક સ્વાગત કરું છું. 2012 થી નેશનલ મેથેમેટિક્સ ડે દર વર્ષે 22 ડિસેમ્બરે ઉજવવામાં આવે છે. હું વેલકમ એડ્રેસ માટે ડોક્ટર પૂનમ ભાર્ગવ મેડમને આમંત્રિત કરું છું. Professor Kunjan Shah, આપણી સમક્ષ ડોક્ટર હર્ષદ પટેલ, ઓનરેબલ વાઇસ ચાન્સલર IIT ગાંધીનગર, હાજર થઈ ગયા છે. સૌ મહેમાનોને હું કહીશ કે તે પોતાનું સ્થાન ગ્રહણ કરે સ્ટેજ પર.
Council on Science and Technology and Indian Institute of Teacher Education, Gandhinagar. I heartfully thank VC sir for providing us the opportunity to conduct this program over here and have and also this program is catalyzed and supported by National Council for Science and Technology, Communication Department of Science and Technology, Government of India. So we also thank the NCSTC GOI for providing us the support to conduct this program. And sir, I would just like to bring to your notice that this program is being conducted throughout all the districts of Gujarat as well as at our regional science centers at Patan, Rajkot, Bhavnagar and Bhuj. So all across we are celebrating this program, and our this entire program is being telecast live on the YouTube channel as well. So once again I welcome one and all, and without taking much time I will request Jhalak to take it forward.
થેન્ક યુ મેમ. ત્યારબાદ સૌ વિદ્યાર્થીઓને હું કહીશ કે હવે યુનિવર્સિટી સોંગ માટે ઊભા થઈ જાઓ.
Avidyam viha vidyate, nahi jnanena sadrisham. उचित सम्मान परंपरा ने प्रयोग के थाय उचित सम्मान तुझे कोटि कोटि अभिनंदन तुझे कोटि कोटि अभिनंदन IIT तुझे वंदन IIT तुझे वंदन सुराशना निर्माण में सार्थक कर तू उत्तम शिक्षण सुराशना निर्माण में सार्थक कर तू उत्तम शिक्षण प्रत्येक ज्ञान तणाज्या स्पंदन प्रत्येक ज्ञान तणाज्या स्पंदन IIT तुझे वंदन IIT तुझे वंदन IIT तुझे वंदन IIT तुझे वंदन
ત્યારબાદ હું દીપ પ્રાગટ્ય માટે મંચ પર ઉપસ્થિત બધા મહેમાનશ્રીઓને આમંત્રિત કરીશ કે તેઓ દીપ પ્રાગટ્ય કરે. મંચ પર ઉપસ્થિત મહેમાનશ્રીઓના ફ્લોરલ વેલકમ માટે હું ડોક્ટર નરોત્તમ સાહુ સરને આમંત્રિત કરીશ કે તેઓ બુકેથી ડોક્ટર હર્ષદ પટેલ ઓનરેબલ વાઇસ ચાન્સલર IIT ગાંધીનગર તેઓને બુકે દ્વારા સ્વાગત કરશે. તાલીઓથી વધાવી લઈએ. થેન્ક યુ સર. ત્યારબાદ હું ડોક્ટર પૂનમ ભાર્ગવ મેમને આમંત્રિત કરીશ કે તેઓ ડોક્ટર ગદાધર મિશ્રા પ્રોફેસર ફોર્મર પ્રોફેસર IISc બેંગ્લોર એન્ડ વિઝિટિંગ ફેકલ્ટી એટ IIT ગાંધીનગર તેઓને બુકે દ્વારા સ્વાગત કરશે. ત્યારબાદ હું મિસ્ટર પાવિત સરને આમંત્રિત કરીશ કે તેઓ ડોક્ટર HC પટેલ રજિસ્ટ્રાર IITE તેઓને બુકે દ્વારા સ્વાગત કરશે. ત્યારબાદ હું પ્રોફેસર કુંજન શાહ સરને આમંત્રિત કરીશ કે તેઓ પ્રોફેસર પ્રેરણા શીલત મેમને બુકે દ્વારા સન્માનિત કરશે.
Being engaged as visiting faculty at Indian Institute of Technology, Gandhinagar, and he is very kind to give his consent, and we are very fortunate to have his time on this auspicious day. We have Professor Dr. Harshad Patel, Honorable Vice Chancellor of IITE Gandhinagar, which able leadership. The university is prospering in a wings and with all its figures, with all its academic excellency. We have Dr. S.C. Patel sir, Registrar, IIT, Dr. Prerna Selat Ma'am, the Director, Dr. Kunjan from Mathematics Department, who is coordinating this event, and all our distinguished faculties of different departments of this IIT, all the students and our invited students from other universities, Kadi and other universities who are gathering here, and who is been participating this very historical and very important significant program, National Mathematics Day, which was initiated by Government of India, Department of Science and Technology in 2012. So, why we have it dedicated, why the Government of India was celebrating this one day with a dedication to this mathematics. We have a brief movie, and in fact we have a link for the bigger movie on life, history and work, pioneering work of Srinivasa Ramanujan. He is such a genius and a genuine person. At the age of 18, when our student, in fact our kids are just entering to the college or completing their standard 12, he has entered to a different world of mathematics. And during that time, whatever the thought process he was taken carry at that time, whatever the expressions he was writing, whatever the deductions he was discussing with the professor, it was unimaginable. I think last year, 2 years before, there was a movie was there, The Man Who Knows Infinity. I think almost of you have seen. We have also using this today as celebration all across the state. So this is a very inspiring program like this thing. But unfortunately, 18 years incentives, insights and thought-provoking pathways. Definitely, we can fulfill the dreams of Honorable PM, and we can again bring that type of laurels and that type of accolades that we had during this life and contribution of Srinivasa. With this word, I once again convey my greetings and good wishes to all those who are participating here physically, those who are attending us on the live streaming, and we would like to celebrate this Mathematics Day not only today but every day in 365 days of the calendar, and to be inspired by Srinivasa Ramanujan, our C.V. Raman, the great mentors, those who are there, those who are here with us. So thank you everybody. I would like to thanks, and I think we have a meaningful and very impactful program with the presence of our two mathematicians, Professor Gandhinagar Mishra sir and Harshad Patel sir, and the faculty here. Thank you.
Honorable Vice Chancellor, IITE Gandhinagar, તેઓની સ્ટેજ પર આમંત્રિત કરીશ કે તેઓ પ્રેસિડેન્શિયલ એડ્રેસ આપે.
રાષ્ટ્રીય ગણિત દિવસ સમગ્ર રાજ્યમાં આ કાર્યક્રમમાં ભાગીદાર બની રહેલા ગણિત શિક્ષકો અને વિદ્યાર્થીઓ અને આ ઓડિટોરિયમમાં બેઠેલા સૌ ગણિત પ્રેમીઓને શુભ સવાર. આજે સવારે જ થોડા મહિના પહેલા બેંગ્લોર એરપોર્ટ પર જ્યારે રામાનુજનનું સરસ મજાનું એક ચિત્ર છે એને કેવી રીતે મૂકવામાં આવ્યું છે એ જો આપણે ત્યાં જઈને જોઈએ તો જ ખબર પડે. ફોટોગ્રાફમાં આપણને માત્ર દોરેલું ચિત્ર દેખાય, પરંતુ કઈ રચનાઓથી એ આખી એમની ઇમેજ ઊભી કરવામાં આવી છે એ મહત્વનું છે. બેંગ્લોર IISc કેમ્પસમાં જવાનું થયું હતું, જ્યાં મિશ્રા સરે વર્ષો સુધી સેવા આપી છે. ત્યાં નેશનલ કરિક્યુલમ ફ્રેમવર્ક જુદા જુદા જે બની રહ્યા છે સ્કૂલ એજ્યુકેશનના, અને મોટા ભાગના સ્ટીયરિંગ કમિટીના મેમ્બર્સ બેંગ્લોર ખાતે રહેતા હોય છે. રામાનુજનજીને આપણે યાદ કરીએ, એની સાથે સ્ટીયરિંગ કમિટીમાં મંજુલ ભાર્ગવજી પણ યુએસ થી આવતા હોય છે, જે આપણા પેલું 20 અને 30 આપણે કહી શકાય ગણિતમાં, એ પ્રકારનું વ્યક્તિત્વ છે. ત્યાં એક મનીષભાઈ પણ છે, જે આઈઆઈટી ગાંધીનગરમાં કામ કરે છે, ગણિતમાં જુદા જુદા પ્રયોગો અને સાધનોની મદદથી બાળકોને કેવી રીતે શીખવી શકાય. એટલે આઈઆઈએસસી થી આઈઆઈટી અને આઈઆઈટી થી IITE. અને આપ સૌને જાણીને આનંદ પણ થશે કે સરે વર્ષો સુધી RI ભુવનેશ્વર ની પ્રેક્ટિસિંગ સ્કૂલ સાથે એને બેચમાં ત્યાં અભ્યાસ પણ કર્યો છે, એલ્યુમનાઈ છે. સરનું સ્વાગત છે આઈઆઈટી પરિવાર તરફથી. ગુજકોસ્ટ સાથે રાજ્યની જુદી જુદી શાળાઓ એટલે માધ્યમિક અને ઉચ્ચતર માધ્યમિકની ક્વિઝ કોમ્પિટિશન યોજવામાં આવે છે. એટલે એસસી પટેલ જ્યારે ગુજકોસ્ટમાં કામ કરતા હતા એ સમયે 2 વર્ષ સુધી અમે એક ક્વિઝ બનાવેલી. એટલે એ રીતે ગુજકોસ્ટ સાથે લગભગ 1 વર્ષ પહેલાથી જોડાવાનું સૌભાગ્ય પ્રાપ્ત થયું છે. અને સતત સાહુ સર આપણને કોઈ પણ કાર્યક્રમના માધ્યમથી અથવા સેમિનારના માધ્યમથી, અને સાયન્સ સિટીમાં આપણે જે સૈનિક સ્કૂલના ટીચર્સ આવે છે એમની પણ વિઝિટ રાખીએ છીએ, જેથી કરીને ગુજરાતનું એક નજરાણું એ સમગ્ર દેશમાં જોતા જાય. આપ સૌ આજે ગણિતના સંદર્ભમાં એકઠા થયા છો. એટલે સ્નાતક કક્ષાએ ગણિત મારો વિષય રહ્યો છે. અત્યારે વિશ્વમાં સૌથી વધારે જેની ચર્ચા છે એ ગણિત વિષયની છે. પ્રાથમિક શિક્ષણમાં પણ આપણે નિપુણ ભારત એ ચલાવવું પડે છે, ન્યુમરસી માટેની વ્યવસ્થા. સ્ટેમ એજ્યુકેશનની આપણે ચર્ચા કરીએ છીએ. એટલે હાયર એજ્યુકેશનમાં પણ, અને આપણે જ્યારે ટીચર ટ્રેનિંગ ઇન્સ્ટિટ્યૂટ હોઈએ ત્યારે ગણિત એ બોરિંગ ના લાગે. ગણિત શબ્દથી જ કોઈને પેલો હાવ ઊભો ના થાય, ડરનો માહોલ ઊભો ના થાય, પણ ગણિત શીખવાની મજા આવે એ પ્રકારના પ્રયોગો અને એવી પદ્ધતિઓ આપણે સૌ આપણી તાલીમ દરમિયાન અને શીખવાની પ્રક્રિયામાં અપનાવીએ તો ભવિષ્યની પેઢીને ગણિત પ્રત્યે રુચિ પેદા કરતા કરી શકીએ. એ સંગીત હોય કે ચિત્ર હોય, ભલે એનું એક્સપોઝર એ માધ્યમથી આપણને દેખાતું હોય, પરંતુ એના મસ્તિષ્કમાં ગણિતની સંરચનાઓને આધારિત જ એ આપણને જોવા મળે છે. આપણે એનાલાઇઝ નથી કરતા કે એ બંને વચ્ચેનો કોરિલેશન પોઈન્ટ 1 ની નજીક જાય છે, ગાઢ સહસંબંધ છે. તો આવી નાની નાની બાબતો જ્યારે આપણે સમાજ સમક્ષ મૂકશું ત્યારે દરેક વ્યવસ્થાને ગણિતની રીતે જોવાનો દરેકનો અભિગમ બનશે. ઘણીવાર વર્તમાનપત્રોમાં આપણે વાંચીએ છીએ કે રિક્ષા ડ્રાઈવરના પુત્રએ આ સફળતા મેળવી ને પાણીપુરી વાળા દીકરીએ આ સફળતા મેળવી. તો માધ્યમો ઘણીવાર એ ભૂલી જાય છે કે સુખી સંપન્ન સુવિધાયુક્ત વાતાવરણ જ એ શૈક્ષણિક સિદ્ધિ તરફ લઈ જાય એવું હોતું નથી. અને રામાનુજન એનું ઉત્તમ ઉદાહરણ છે. એટલે આપણી સરકારી પ્રાથમિક શાળાઓ વનવાસી ક્ષેત્રોમાં છેવાડાના માનવીમાં એવા ઘણા બધા વિદ્યાર્થીઓ પડ્યા છે કે જે વૈશ્વિક કક્ષાની પ્રતિભા નિખરી શકે તેવી સંભાવનાઓથી ભરપૂર છે. અને ઇન્ફિનિટીનો મેસેજ જ આ છે. એટલે આજના દિવસે આપણે સૌને એ પ્રકારના સંકલ્પ લઈએ અને એવા વિદ્યાર્થીઓને શુભેચ્છા પાઠવીએ કે ભવિષ્યમાં માનવ જાત માટે ગણિતના માધ્યમથી સેવા કરી શકે. આ કાર્યક્રમમાં આપ સમક્ષ 2 શબ્દો બોલવાની મને જે તક મળી છે, અવસર પ્રાપ્ત થયો છે, એ માટે ગુજકોસ્ટનો પણ ખૂબ ખૂબ આભાર અને સર્વ સહભાગીઓને પણ અભિનંદન. જય હિન્દ, વંદે માતરમ.
થેન્ક યુ સર. ત્યારબાદ આપણે એક શ્રીનિવાસા રામાનુજન સરની એક શોર્ટ ફિલ્મ છે જે અહીંયા પ્રસ્તુત કરવા જઈ રહ્યા છીએ. સૌ મહેમાનશ્રીઓ પોતાનું સ્થાન ગ્રહણ કરો. ત્યારબાદ ઇન્ટરેક્ટિવ ટોક માટે પ્રોફેસર ગદાધર મિશ્રા, જેઓ ફોર્મર પ્રોફેસર ઇન્ડિયન ઇન્સ્ટિટ્યૂટ ઓફ સાયન્સ બેંગ્લોર અને અત્યારે હાલમાં વિઝિટિંગ ફેકલ્ટી છે ઇન્ડિયન ઇન્સ્ટિટ્યૂટ ઓફ ટેકનોલોજી IIT ગાંધીનગર. તેઓને મંચ પર હું આમંત્રિત કરીશ કે તેઓ તેમનું ઇન્ટરેક્ટિવ ટોક આપે. સર ઇન્ડિયન સ્ટેટિસ્ટિકલ ઇન્સ્ટિટ્યૂટમાં પ્રોફેસર બી રહી ચૂક્યા છે, જેમણે SS ભટનાગર પ્રાઇઝ, બીજુ પટનાયક એવોર્ડ ફોર સાયન્ટિફિક એક્સેલન્સ, એલ્યુમની એવોર્ડ ફોર એક્સેલન્સ ઇન રિસર્ચ જેવા એવોર્ડ્સ બી પ્રાપ્ત કરી ચૂક્યા છે. સો આપણે તાળીઓથી વધાવી લઈએ સરને. નાસ્તો કર્યો તો કે નહીં બરાબર?
I thought my voice is loud enough. I usually don't use a mic, but I think if I keep it away, perhaps it will be easier. But anyway, let me try this. I'm really very, very glad to be here. I was telling the story of how the National Mathematics Day was conceived, and I was sort of involved in that. In 2011, which was the 125th birth year of Ramanujan, we had a year-long celebration all over the country, and it culminated in a meeting in Chennai with the Prime Minister, Mr. Manmohan Singh, and Robert Keniger, who had written this book, The Man Who Knew Infinity. And that's when the Prime Minister actually declared December 22nd to be the National Mathematics Day. It had taken some effort to actually make it happen. The thing is, then there were events that were organized in the following years, but it hasn't been very regular or something that is done in any kind of systematic way all over the country, and that is very unfortunate. It did take a lot of effort to get it to be the National Mathematics Day, and then it has been not been celebrated in the way that it deserves. Whereas I'm really happy that here in Gujarat, not only that it's happening here in this place, but as I learned just now, it is happening all over the state, which is a matter of great happiness for me, because as I said, there was a lot of work that went into actually declaring this as the National Mathematics Day. So having said all that, I wasn't sure what an interactive session meant, so I came prepared with different things, and I'll try to choose something or the other. Please let me know at some point if you think one should do things differently. I actually assume that there might be actually school students, so different levels of things that I have in mind, but we'll see. Let me just show you a couple of slides. We already saw Adi and Ramanujan. One of the very early letters of Ramanujan, which is talked about today with a great deal of mysticism, if you like, is that expression 1 plus 2 plus 3 is equal to -1/12. Who in this auditorium would ever feel that if you add up 1, 2, 3 and so on, you will end up getting -1/12? Now that's on the one hand the genius of Ramanujan. On the other hand, it is also call it madness, call it whatever. I mean, before I go on with, it's not easy for me to explain, or there are perhaps only a handful of people who will sort of really know or understand the significance of an expression like that, other than to dismiss it right away, saying that how is this possible? And the difference between being a genius and being somebody who is stupid is very little actually. So in this case, it turns out we were fortunate that Ramanujan was indeed a genius. I'll just follow through a couple of slides to tell you what his proof was. This was his proof. 1 plus 2 plus 3 plus 4 and so on. Call it by some name. Let's say C. He called it C. As you can see, this is his handwriting. 4C is equal to 4 plus 8. He multiplies the right hand side by 4. 4C is equal to that. And therefore by subtracting he gets -3C to be something. And then says that's 1/4. -3C is 1/4, therefore C is -1/12. I won't take too much time, but let me tell you why Ramanujan arrived at that. So just rewriting what you saw in handwritten note, C is equal to that expression. Yeah. So C is that expression, 4 times C is that, therefore minus 3C is whatever. And there I have put a question mark. That is my doing. I have put a question mark there. 1 over 1 plus 1 whole square equal to 1/4. Hence C equal to minus 1 over 12. Let's just look at what's going on here. What is wrong with this? Okay. Without knowing in advance, if the infinite sum, 1 plus 2 plus 3 plus whatever, today any student of calculus will know that you cannot do this subtraction. C minus 4C equal to minus 3C needs a lot of justification. It cannot be done unless the series is convergent. Ramanujan, of course, is Ramanujan, so he just went ahead and subtracted. So that's already something that's problematic. Then it is not clear unless the infinite sum is convergent, why it should equal 1 over 4. Well, something is not whatever. If it is not convergent, why should it be 1 over 4? So now his justification was the following. All of us know the binomial series 1 plus x square. If you stop at a finite sum, that is if it stopped at x to the power n, of course you will say it's a geometric series and you will write down an expression. If the sum doesn't stop, if it is an infinite sum actually, then it's equal to 1 over 1 minus x, as all of us know, with the proviso that x has to be less than 1 in absolute value. X has to be between minus 1 plus 1. Now, why we say that and what lies underneath? Is it really true that x has to be between minus 1 and plus 1? Is a subject in itself. But what we learned in high school or beginning college is that at least if x is between minus 1 and plus 1, there is some way in which you can make sense of this expression, and it is 1 over 1 minus x. Now you go ahead and differentiate it. If you differentiate the left hand side and assume that you can do differentiation as if nobody is watching, you can do whatever you like, because see, differentiating an infinite series also needs some care. But if you just go ahead and differentiate the left hand side, differentiate the right hand side, that's what you do. Okay? And then what does Ramanujan do? He says put x equal to minus 1. Now that is a crime that we are taught not to commit ever. You are not supposed to commit that crime where the series is not convergent, you are evaluating it at minus 1. You are not supposed to do that. But then we get the desired sum. If you put minus 1 over there, that will justify that 1 over. That was Ramanujan's view. It took a whole lot of very, very smart mathematicians to come up and try understand what Ramanujan might have in mind. Okay? And after many, many years, one sort of knows why this is so. I'll not go into this. I had a complete lecture on that, which is, which takes some time to explain what analytic continuation is all about and how you can sort of knowing what a function is doing, let's say between plus 1 and minus 1, how you can extend it beyond that domain of definition. Okay, so that's about Ramanujan. I don't know at this point in what order. As I said, this was meant to be an interactive. Yeah, since many of you, this is a teacher's education sort of institute, just for fun. All of you must have seen the usual proof that P over Q is root 2, then you arrive at a contradiction. Okay, the usual one, you square both sides and then you get even number over even number, but this is in minimum representation, therefore that will be a contradiction. Okay, that's the usual proof. But this is a slightly unusual proof that if you assume square root of 2 is equal to P over Q, just do a little bit of algebra to verify that that actually means square root of 2 must be 2Q minus P divided by P minus Q. But since square root of 2 is bigger than 1, P minus Q is less than Q, and you have reduced the denominator from its minimum. In the beginning you are assuming square root of 2 is P over Q, which means that you are presenting square root of 2 as a rational number where the denominator is as small as possible. But from that you see that you have reduced the denominator by writing it as P minus Q, which is a contradiction. But that's not the point. I mean, there are several ways you can do that. But the fun part is, suppose you have proved that square root of 2 is an irrational number, either by this way or some other thing that you like better. What happens if I want to look at the nth root of 2? Again, it's known that the nth root of 2 is also irrational. But how many of you heard of Fermat's last theorem? But I don't see anybody else raising their hands. Fermat's last theorem? If you raise x to the power n and you want to write it as y to the power n plus z to the power n, except for n equal to 2, you cannot find a solution in integers. That's Fermat's last theorem. In any case, you haven't heard of it, but this was meant to be a joke. That it's a very, very powerful theorem. Fermat conjectured it sometime in 1800 something or the other, and it was finally proved about 20 years ago after using lot of sophisticated machinery and lot of modern mathematics that was available. Whereas Fermat, while making that conjecture that if you have x to the n equal to y to the power n plus z to the power n, you cannot find a solution in integers when n is strictly bigger than 2. He wrote on the margin that he has a proof, but this margin is too narrow to fit the proof. This is a very famous story, like many stories about Ramanujan also that we know. So, but I am writing this down for fun that if square root of nth root of 2 was a rational number, then you will get p to the n equal to 2 times q to the power n. But writing 2 times q to the power n equal to q to the power n plus q to the n, that's just the Fermat's equation. And if it was, if nth root of 2 was a rational number, you will get a contradiction. Now that Fermat's theorem is actually proved, you will get a contradiction to the Fermat's theorem. Okay? So this is one example where you bring a heavy duty machine to really do something very small. I wrote this down just for fun. Okay, now that we have this, I thought I'll do the following. Got something. I'll tell you what to do with this, but can you please distribute this? Yeah, just give it to me. that piece of paper, first of all, what you do is write your name, and you will find 6 tables. One in front, 3 tables in the front, 3 tables in the back. Now think of since we are talking about Ramanujan, we have to write what Ramanujan is like. But think of a number between 11 to 57, let's say. Think of a number between 11 to 57. In any of those tables, if you find the number you have thought of, put a tick mark on that table. Yeah. Even without the mic, I was audible or not audible? No?
Yes.
Oh, I see. Okay. Alright, so my instructions are clear. Write your name. Then think of a number between 11 to 57. And wherever you find that number, in the tables where you find the number that you have thought of, put a tick mark against that table. Okay? So some of you might put a tick mark only on 2 tables, some of you might put a tick mark on 3 tables, whatever. Depends on which number you think of. Just tick the table where your number appears. But please do it carefully. If you make a mistake, I won't be able to do it right. Okay? Actually, I do this with a smaller set of numbers so that you won't. So, okay, if anybody is done, can I have it back? Meaning, give me, if anyone is done thinking of a number and putting the tick mark, so just give me a sample. Let me see if that works. No.
Yeah,
I
she
don't
need to-
want you to mark the
mark that
number
number
itself.
actually, yeah.
I want you to mark, only
to-
put a tick mark
That was
against
the
the
message
table.
that he will tell you that 23 is your number.
If you tell me the number, then there will be no problem.
नंबर शुड नॉट बी सर्कल्ड, आपको वो टेबल को टिक करना है खाली, आपका नंबर आपके पास सीक्रेट रखना है, ठीक है? फॉर एग्जांपल 15 इज द नंबर, तो जो टेबल में 15 आ रहा है वहां पे जाके टिक लगा दो खाली. You should not reveal that number.
So this is Kausal, and I guess if you have marked it correctly, it should be 43. Who is Kausal? 43. No? Then you have missed something. Please check here. That's what I said. This table is perhaps a little bigger than what I would have liked. I'll tell you backwards. You tell me what is the number you thought? 35. So, yeah. Oh, but this was yours. Then I made a mistake. I made a mistake. I didn't read it right. Yours is done? Huh?
टिक कर दिया है.
Yeah. So let me just get it. Yeah, I did not notice that this is yeah. This is 25, right? That 35, I'll tell you why I made a mistake. I didn't read the. Who else? But again, you have put a mark on the numbers. This should be 15, right? Sajal, Saat. This is whose? Sajal. Yeah, from this side. Are you sure it's 1? This is the only tick mark you have, no? But, if that's the only tick mark, 1, that's where else? Huh? What is the number you thought? Huh? 55. But then you haven't marked here, for example. There is 55 in the last table. 55 is many other places. So you are supposed to mark every single table where there is 55, right? You are done.
એ નંબર જ્યાં
This one is-
ટેબલમાં હોય બધા ટેબલ કરવાનું છે.
નંબર ટીક નથી કરવાનો, ટેબલ ટીક કરવાનું. જે નંબર તમે જે નંબર આવે ને જે ટેબલ
Give this.
સિંગલ ટેબલ पे टिक किया है.
Usar. Yeah.
सिंगल टेबल पे किया है.
Yeah, you have ticked only one table, right? That's 4. Huh? You? What? You have done. So these are not numbers you are marking, it is only the tables that you are marking. See, this tick mark here, what does it mean? Is it the number you are thinking or it is only this table that you are marking? No, I want only the table to be marked, right? Anyway, so I think we have had enough of that. Huh? Huh? Yeah, right, you are right. That's the thing. So this was a simple illustration of what you do with numbers. Actually, this is just the binary expansion of a number that you think of, right? Any number that you think of as a binary expansion, which means that if I take, for example, 25, I would write it as 16 plus 8 plus 1, right? And those tables, they have 32, 16, 8, 4, 2 and 1. So any number that can be written as a combination of these powers of 2, it is easy to read it off. You tell me in your number, let's say you say 37, then that is actually 32 plus 4 plus 1. So you mark the table that contains the 4, that contains 1 and that contains 32, because those are the tables where 32 would occur. So there is no way I can make any mistake. There is only one possible manner in which you can represent a number as powers of 2, sums of powers of 2. What will be the coefficients? The coefficients will be only 1 or 0, and that is why there is no difficulty in picking out what number you have thought of, right? So I'll quickly show you another little thing which is not to do with 2 but with 3, and then we will move on. I'll finish with showing you. Can I have the next step? Where is that? Yeah. Okay, so now again, I need a pointer. We will finish with only this magic. We will not do anything more. I'll do one other demonstration because you said it was supposed to be interactive. Is there a volunteer here? I want to play a little game. Somebody?
भी 4 लोग आ जाओ.
No, you just have to tell me, you again, it's the same kind of thing. Think of a card, tell me in what row that card occurs. Do you see, imagine, think of one card.
भाई हमारे नंबर सर की नहीं.
You think of something and tell me which row it is there. Second, okay. Then, now where it is? Again second. Now? Huh? Again second. Now you got it right, right? You want to double check again? I can play this, I mean, in case you think I'm cheating. Is there another volunteer somewhere? Yeah, please. Go back to the desktop. I need that. Oh, okay. Just press again. No, just do the index. Yeah. So now think of a card and tell me which row it occurs.
First row.
First row. Okay. Then
Again in first row.
now.
Second row.
Okay. Not just like I explained the business about the numbers, I'll tell you how this is done. In fact, there is a third magic trick which I'll finish, but this is something professional magicians actually do on a stage. You know, you take a set of cards, you put it on the table and you shuffle it in a certain way, and you play with the audience. Let me tell you how it is actually done. That should be done. Now please look at the rows. If you tell me that you have a card that is in the second row, what is now going to happen? When I sort of press that, the second row is colored in a certain way. What will happen is that when I sort of go to the next one, you'll see how this coloring. Please pay attention to the coloring. Okay, the second row I have taken and broken it up into these. I distribute the second row means what? There are 9 cards altogether. If you look at this, the second row has been made into this. I take the second row, which are 9 cards. Now I have arranged it so that they all occur in the middle column. Okay. Now suppose you go ahead and tell me that your card now occurs in the first row. That means I take whatever was in this thing. So this was supposed to be the second row, right? That you had picked. Now you told me that your card occurs in the first row. I take that first row, I put it along this column, in the middle column again. You tell me a third time where your card occurs. Now suppose you say it is in the third row. Then it gets picked, right? So that is how it is done. And there are several, actually from here one could sort of play with polynomials, do many other things, go to the Cantor set and so on and so forth. But since we are perhaps almost running out of time, I'll do one last thing. I don't know if you have seen. I think while I want to show you something, again, because this was meant to be interactive, I came prepared to be interactive. Okay, so you have to participate, right? Now I have something in my hand. Okay, I have something in my hand. We are going to play this game, and let me assure you, before you think you are getting completely bored and you have better things to do in life, I'll finish. This will be the. So let me give you a little bit of clue. So, one of you. can you sort of just make it into a strip, right? Yeah. You understand what I'm saying? So just paste it together like this, right? And then make it into a cylinder at the end. Then, right? Okay, I'll show you in one. Just do it like this. Right? Except make it big if you like. Let's not even make it big. Let's just make it small. No, wait. You don't need it to be that. Just hold on. Okay? Leave the other things. Alright. So, look, come here. Please. So you see, this is something, right? All of you have seen things like this. Now please kind of cut it in the middle along this red line. Just cut it in. That also. But yeah, it will fall apart. Yeah, that's true. So you don't have to be very careful or anything. You just cut it in the middle. You cut it like the way you said. Right? No surprise. Okay. Now. Oh, right. Now, you cannot cut it in the middle like that. But what is the, I mean, do you see that this is the same thing or what? How? You could do one or two like that also. But what do you think will happen if I cut it? Okay, first of all, let me of course show you that if you do this, yeah, this is the Mobius band. If you do this, you can see that there is a red line here outside that remains outside and not going anywhere. Inside, there is a blue line. So these are the region, there is a blue and a red separate, is because this has two sides, if you will. There is a inside, right now the inside is red, the outside is blue. On the other hand, if you look at this, yeah, you cannot say which is right, I mean which is inside, which is outside, because if you go along the red, like that, you are coming from outside here, coming like that, but now you are in the blue, okay? So, this is what is called a one-sided surface. It is not entirely a joke. Some of you may or may not know, since these days there is a lot of talk about applications and people sort of demand, why are you wasting everybody's time talking about Mobius strips and such. Many of you may or may not know that there is what is called a conveyor belt, which means there are two wheels and there is a belt that is rotating. Now what happens is, if you put the belt of the kind like this, So here there is a wheel, here there is a wheel, and this belt is rotating. What will happen is the inside of the belt gets worn out very quickly, or at least one side gets worn out. Now the Mobius strip, actually in many modern conveyor belts, a deliberate half twist is given. So that what happens is, if the belt is very big, the wheel doesn't see that there is a half twist. It rotates quite well, except the surface is sometimes inside, sometimes outside. So the wear and tear is actually uniform. And here is one of the most amusing applications of something that I consider to be abstract mathematics that I have ever seen. There are other things that you can do with the Mobius strip, but just to finish, of course, one could do number of other things. I wish I had the. So now you keep cutting. So as he demonstrated just now, if you cut in the middle, it is supposed to just fall apart. And here is a Mobius strip. I wanted to make it a little bigger so that you won't be able to notice that there is a twist in the middle. In fact, this goes back to one of my very early experiences when I was 8 or 9 or 10 years old. There was a magician who came to Bhubaneswar, and he had a strip that was going all over the stage, perhaps 20 meters or something. And there is no way that you could see the twist that was there. And he started cutting like this. And as I said, that was 50 odd years ago. And I was very impressed. I mean, he cuts something in the middle, and then what happens is that it sort of, my making it so big did not help, because he was able to immediately see that there is a twist. And of course, now there are many more things that one could do with this. I mean, as I said, I have already told you one application of this. In fact, I brought this bigger one to show you a couple of other things, namely that if you could do this, but then okay, that's what we just now saw. But if you continue doing one more time, now you know what will happen. It will become nuts. Yeah. So that I'll leave aside. But let me very quickly finish with one other thing which I like to make a statement as something like, yeah. Thank you very much. Yeah, this. Let me just quickly, is it okay to spend another 5 minutes? Yeah. Okay. So this is something that I like very much, and I want to give a social message by playing this game again. In fact, I had brought something else also to play that game. This will require 2 volunteers and so on and so forth. So let me just show you what it is. You just stack up wooden blocks like this. Yeah. Stop. I think perhaps what you have to do you can play this game in the following way. You take this pile and divide it into two piles. Okay. Like, suppose you divide it like this, then what will happen? Here there is 2, here there is 6, and you get 12 points. Okay.
So that everybody can see.
So there are 8 altogether. So if you divide it into 6 and 2, you get 12 points. In the next step, you take this and this, you split it into 1 and 1, then you get only 1 times 1, 1 point. In the third step, suppose you divide this into 3 and 3, you get 9 points. You keep doing this. Now I divide it like that, then I get 2 times 1, here I get 2 times 1, but then I divide this, I get 1 and 1. Everything becomes 1, right? And then I add up all the points. I add all the points. Whoever has more points wins, okay? So the question is who wins? Whether the green ones? Yeah. Huh? Yeah. You want me to explain again? Okay. So, to begin with, by the way, this happened, actually I learnt of this game because everything is online today. Some professor was teaching in MIT and he asked his class to actually come up and play this game with him. So, here is the game. You start. I mean, by saying that you divide it like this. So then what happens? Here there are 5 and here there are 2. 6. No, actually let's do it with 7. So that will match with my slides. So, so suppose you do it like this. Now I'm 4 times 3, you get 12 points. Now you divide. No, you can divide in some other way. Okay, so suppose you divide it as 2 times 4, you get 8 points. C gets 7 points, right? In the next step, you decide that you divide it like this. 3 times 2, 6 is what you get. And maybe C divides it like this. Only 3 times 1 is 3 points. So we keep adding these points together. And finally in the end, whoever has more points wins. Is that clear? Okay, so let's start. So you just take turns, each one divides into two parts, okay? And then we will multiply. Is there a scorekeeper? Can you, yeah, now you divide this into 2 parts in any way that you like or you think is convenient. So how many is that? 3 and 4. So you get 12. Now you do it. 2 and 5. So 10. Yeah. Now you do whatever you want to do. You can divide it in any way that you like. So that's 2 and 1. Sorry, 2 and 2. That is 4. So you get 3 and 2. So that's 6. Right? Okay. So 4 and 6. 4 and 6 in the second step.
Yeah,
right. Yeah. Now you please do it. We'll finish in 2 minutes now. Okay. So that's 2 and 1. That is 2. He also gets 2. Now you get 1. He also gets 1. You get 1. That's 1. That's 1. Okay. So what happened? What did you get for this score?
20 for the Itisha. 20. Both 20.
Both 20. Yeah. I'll tell you why both 20. And then I'll stop. I'll comment. The point is, here is a game, you can go back and thank you very much. I said something about social message. Right from the beginning, I have been very unhappy about the way we do things. Namely, somehow saying that you have to get ahead of others. You have to beat somebody else so that you can prove you are good. Now I have always imagined a society where there is no such thing. We are who we are. We are not good or bad because somebody else is something. Okay? This has bothered me a lot. This whole business about saying somebody is the best, the other one is sort of next best and that kind of thing is a very worrisome concept as far as I am concerned. In fact, all the little kids, we teach them how to win. And to me, that destroys the fun of childhood. There is no such thing as winning. One shouldn't be really worrying about winning. I don't know, maybe I haven't been able to sell this idea very much, but let me finish by saying this game is wonderful in the sense that no matter what you do, nobody wins. It's always the same score. Nobody ever wins. So I'll go through these slides very quickly. So you have already seen how the game is played, so I don't have to. So the number of points you earn is the total of points you earned at each step, okay, like the did, and the goal is to get the maximum points. So at this point, when you have these 7 blocks, your score is 0. If you divide it into 4 blocks each, your score is 16. Then you divide the 4 remaining block into 2 and 2, you get 4. So that becomes 16 plus 4, 20. And you keep doing like this until you become 1, 1, 1. And you add up the scores. Because here there are 8 blocks as opposed to 7, you end up getting 20, 24, 4, 28. Okay? The previous one was 20. You will see why it is 20. But now I'll quickly go over. Can somebody do better than 28? And the answer is no, because it's an inductive proof, but it says that it will have to be n times n plus 1 divided by 2. Okay, so there is something here that I have written down about how you do the induction. The proof is by the principle of strong induction, and you say Pn is a property that applies to natural numbers such that following are true. P0, P1, P2 all the way up to Pk is true, then Pk plus 1 if you verify to be true, the entire statement P then is true, irrespective of K. That is the principle of strong induction, and using that principle of strong induction, you can actually show that that the answer is always n times n plus 1 divided by 2. Since we are at the end of this, what was meant to be an interactive session, I will not keep you very much longer. These things are actually on my homepage, so in case anybody cares enough to look them up, these details are there on the web, on my web page, and therefore I'll stop here, thanking all of you for such a deep support.
ડોક્ટર નરોત્તમ સાહુ સરને સર એક મિનિટ મોમેન્ટો આપવા માટે ડોક્ટર નરોત્તમ સાહુ સરને આમંત્રિત કરું છું કે તેઓ પ્રોફેસર ગદાધર મિશ્રાને મોમેન્ટો દ્વારા સન્માનિત કરે.
Thank you. Yeah.
Thank you, sir.
અંદરના બહાર ના હો ભાઈ.
હવે પ્રોફેસર કુંજન શાહ, જેઓ IIT ગાંધીનગરમાં મેથ્સના પ્રોફેસર છે, તેઓને સ્ટેજ પર આમંત્રિત કરીશ.
Hello. Very good morning to all. Actually, sir, it has been such an honor to be here on this wonderful event, and for that, I would first like to thank our Honorable Vice Chancellor, Dr. Harshit Patel, sir, since he has very busy schedule, although he's come here for motivating us. And next, I would like to thank the advisor, GUJCOST, Dr. Narottam Sahu, sir. Actually, I would say that we are just here to give you the facility, otherwise the whole program concept is actually by yours. Okay, so now I would like to thank the Poonam Bhargava ma'am and her team for conducting this wonderful session, and all the IIT colleagues, and last but not least all the participants from the KSV and IIT students. Since our student has the exam, although you can see that our students are here and they have the exam at the 10 o'clock, so they leave that auditorium at 9:55 and they are actually here, so I must thankful to all of you. Okay, thank you so much. And at the last, I would like to quote one, that there is never a wrong time to do right things, and I think this is the right thing that we have to see. And I actually, sir, that is one request to you, sir, that sir, since you are, I know that, sir, you are the expertise on the operator theory, which is the part of the real analysis. So you motivate some, since you are the neighbor to us, if you have some time, we will invite you and motivate our student to do some good thing on the real analysis. Thank you all that. Thank you, sir.
નેશનલ એન્થમ માટે બધા પોતપોતાના જગ્યાઓ પર ઉભા રહે.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता. पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा. विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा. तव शुभ नामे जागे, तव शुभ आशीष मांगे. गाए तव जय गाथा, जन गण मंगल दायक जय हे भारत भाग्य विधाता. जय हे जय हे जय हे, जय 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 हे.
રિફ્રેશમેન્ટ માટે પાછળ હશે તે નાસ્તાના પેકેટ્સ હશે. પાછળ આપણે મેથેમેટિક્સ ડેની સેલ્ફી પોઈન્ટ બી રાખેલ છે.
For getting a good photograph, you will have a selfie point just behind this auditorium.
Video
and you will
clip
get some refreshment also. So I would request all the students to proceed.
અરે યાર તને વધારે ભૂખ લાગે દિશા બહુ વધારે નાટક ના કરે ચના ભાઈ એટલે માથી ડરી